Yesterday, you guys reviewed solving systems by graphing. Today, we're going to review solving systems of equations by substitution method. Okay, the first step to substitution method says solve one of the equations for one of its variables. Step 2, box it up and ship it out. Step 3, solve the new equation for the given variable. Step 4, put your answer back into the box. And then step 5, write your solution as an ordered pair. X value first, Y value second. Alright, so let's try an example here. So if we look at the system over here on the right, we got two equations. Y equals 6x minus 11, negative 2x minus 3y equals negative 7. Let's look at our steps. Step 1 says solve one of the equations for one of its variables. So you get two equations to choose from. You want to pick one of the equations and solve for either y or x. Well, the first equation is already solved for y. So step 1 is done for us. Now we go to step 2. Step 2 says box it up and ship it out. So the equation that's solved for either y or x, we're going to box that up, okay, and then ship it out. Well, we're going to ship it out to the equation that we haven't used yet. So the second equation here. This box is equal to y. So when I ship it out, I'm going to ship it out for the variable y. So I got step 2 done. Step 3 says solve your new equation. So you get a new equation here. When we ship out the box, we're going to have negative 2x minus 3. But instead of having that y there, we're going to put the box in place of it. We're substituting 6x minus 11 in place of the y. So this is our new equation. So this is step 3. We want to solve this equation for x. You can treat the box like it's grouping symbols. So what we're going to have to do is we're going to have to use the distributive property. Negative 3 times 6x would be negative 18x. Negative 3 times negative 11, positive 33, is equal to negative 7. Now we're going to combine our like terms. We got negative 2x and negative 18x, and that makes negative 20x. Plus 33 equals negative 7. So subtract 33 from both sides. We get negative 20x is equal to negative 40. Divide by negative 20. X is equal to 2. So we just completed step 3. Now step 4 says put your answer back into the box. So our answer is x equals 2. So we're going to put that back into the box. So we're going to plug 2 in for x inside this box. So inside the box, what we have now is 6 times 2 is 12 minus 11, which is 1. And what does the box equal? It equals y. So y equals 1, x equals 2. And then the final step I always want you to do is write it as an ordered pair. So the solution is the point 2, 1. If we were to graph these two equations, this is where the two lines would intersect at that point, 2, 1. All right, I want to do some more examples here. Let's look at this example. There's our system of equations. Remember, your first step is to solve one of the equations for either x or y. So if you look, neither one of these equations is solved for x or y. But if you look at the first equation, it would be really easy to get the y by itself. What we could do to the first equation is add 4x to both sides of it. So that gives us y is equal to 6 plus 4x. So I'm going to box this up. And what does this box equal? It equals y. So I'm going to ship it out for the y in this equation. So we have negative 5x minus this box, 6 plus 4x. I always put it inside a box, so if you don't want to put it inside a box, you can put it inside parentheses, but it's a good habit to do. Is equal to 21. So we gotta get rid of the parentheses or the box. So remember, we're going to use the distributive property. We got a negative sign, but there's a 1 there, an invisible 1. So we're going to have negative 5x, negative 1 times 6, negative 6, negative 1 times 4x is negative 4x is equal to 21. Add or like terms. The negative 5x plus the negative 4 would be negative 9x. And I'm going to have to move the 6 to the other side, so let's go ahead and add 6 to both sides. We get negative 9x is equal to 27. So divide both sides by negative 9, and we get x is equal to negative 3. So now we take our answer, x equals negative 3, plug it back into the box, and work it out. This will be how you get your y value, or your second value. So we got 6 plus negative 12, which is equal to negative 6. And then again, always write your solution as an ordered pair. X first, y second. So the solution to this system is the point negative 3 comma negative 6. Okay, let's solve another one. Example 3, solve the given system. So again, we're going to look for what's going to be the easiest variable to get by itself. Well, that's going to be the y in the second equation. So we can add x to both sides. So we get y equals 3 plus x. So we're going to box that up. We're going to ship it out to the y in the first equation. So I'm going to rewrite the first equation, and I got negative 3x plus 3 times this box is equal to 4. So negative 3x, 3 times 3 is 9, 3 times x is 3x, equals 4. Combine our like terms. Negative 3x plus 3x is 0x, or just 0. So these cancel each other out. And we get this. 9 is equal to 4. So this is one of those special cases that you learned about yesterday. It's either no solution or infinite many solutions. Well, does 9 equal 4? No, this is not true. So the solution to this system would be no solution. What does that mean if you graphed it? That means if you were to graph these two equations up here, these two equations would be parallel. They would not cross. If we would have worked this out and we would have got an answer like, let me just, if we would have worked it out and got an answer like 9 equals 9, then this is the other special case. This is the infinite many solutions. And that's where you graph them and they're the same line. So they're intersecting infinite amount of times.